Here we go. This is our lesson on the Great Chicago Fire. Everybody, we're going to do a little history. Oh wait, this is not social studies, this is math. Got to do g.c.f. g.c.f. stands for actually greatest common factor. Sorry about that. That was a mistake. Okay, so here's some vocabulary that you need to know. You need to know what a factor is. I think we've actually covered this previous to this lesson, but I'm going to go over it again anyway. So a factor is all the whole numbers that can evenly divide into another number. So it has to go into it evenly. It has to divide into it evenly. You can't get a remainder or a decimal. One way that I like to factor is using factor pairs. Factor pairs are basically multiplication problems that make that number. So what I mean by factor pairs is that 3 and 4 is a factor pair of 12. 6 and 2 is a factor pair of 12 because those numbers multiply and make that number. 3 and 5 are a factor pair of 15. 2 and 1 is a factor pair of 2. So it can be a number in itself too. Make a little T table, a T chart, on how to find the factors of 36. Now the factors of 36, when we do this, let's start with 1. And just keep asking yourself, what times 1 is 36? What times 1 is 36? And it's 36. So that's your first factor pair. And let's move on up, starting at 1. So let's go to 2. Does 2 divide into 36? Yes, it does. 2 times 18. 2 times 18 is 36. Does 3 divide into 36? It does. 3 times 12. And then 4 pairs up with 9. 6 pairs up with itself. So when you list all the factors of 36, you get that. Okay? You're going to get all these numbers right here. Okay, now notice I didn't write 6 twice. Okay. So our factors are 1, 2, 3, 4, 6, 9, 12, 18, and 36. Those are all the factors of 36. Those are all numbers that 36 can be divided by. 36 divided by 9 is 4. 36 divided by 6 is 6. 36 divided by 18 is 2. Etc., etc. Here, let's do some more practice here of factoring a number. Don't confuse listing factors with prime factorization. You might have done factor trees where you've done something like this and you get a number like 6 and 8 and you keep doing a factor tree. We're not doing that yet. We will eventually, but that's not what we're doing. All we're doing is purely listing the factors of 48. So I'm going to do a table again and just work on down the line. 1 pairs up with 48. 1 times 48 is 48. 2 pairs up with 24. 3 divides into 48. Now, so you're probably asking yourself, how do we know 3 divides into 48? And that goes back to the divisibility rules. 4 and 8, when you add them up, add up the digits, 48. 4 plus 8 is 12. Does 12 divide by 3 evenly? It does. So that means 48 divides by 3 evenly. 3 times 16. Okay, now you wouldn't know that if you didn't know your 16 tables. Nobody does, but you do know the divisibility rule for 3, so don't count out 3. 4 pairs up with 12. 4 times 12 is 48. 6 pairs up with 8. And that is it. We're done. The only number in between 6 and 8 is 7, and 7 does not divide into 48. 7 divides into 49, but that's not our number. And there's all of our factors listed out. Okay, notice I'm using this set symbol. Okay, these are called braces. Okay, but usually if you're listing a set of numbers in math, we use these little grouping symbols right here. They're called braces. Set notation is also another way to put it. You don't really need to know that, but if you're confused by how I'm writing it, that's what I'm doing. List the factors of 15. 15 pairs up with 1 in itself. That is always going to be true. Always start out with the number in itself and then work your way up. 2 does not divide into 15, so let's go to 3, and 3 times 5 is 15. And that is it. 4 does not divide into 15. And 5 does, but we already have that listed. So there are all your factors of 15. Let's list all the factors of 31. 31 only has 1 in itself. That's it. But just because it's prime doesn't mean it doesn't have any factors. A number will always have 2 factors, 1 in itself. And now let's focus on finding the factors of 2 numbers, okay, and see where that leads to. So 42 and 60. So let's list all the factors of 42. 42 is 1 and 42. 2 times 21 is 42. 3 times 14 is 42. 6 times 7 is 42, and that does it for your factors of 42. Notice how when we're doing this, the numbers get closer and closer and closer together. And the only difference between 6 and 7 is 1, and that means you're done. There's no number in between 6 and 7 that can divide into 42. That would not be a decimal. So we can't use decimals. We can only use whole numbers. So that is it for 42. Let's go on to 60. 60 is 1 and 60. After 1, let's try 2. 2 and 30. After 2, let's try 3. 3 and 20. 4 and 15. 5 and 12. 6 and 10, and that does it. Okay, now let's circle all the factors that 42 and 60 have in common, because that's what the question was. We're finding all the common factors between 42 and 60. All right, so what do they have in common? They both have a 1 in common. That will always be true. They both have a 2 as a factor. They both share a 3. They both share a 6. And that does it. So their common factors are 1, 2, 3, and 6. So where am I going with this? Now, I notice in the question here, all I asked you to do was find all the common factors between 42 and 60. But I can easily change the question here and ask you, what's the greatest common factor? Greatest common factor. Well, it's not 1, it's not 2, it's not 3, it's 6. That's the greatest common factor. That's the largest number that 60 and 42 is divisible by. That is a factor of 42 and 60. So that's it. That's your g.c.f. right there. Now, I didn't even mention, at the onset of this problem, I didn't even mention that this was a g.c.f. problem. So all we did was we listed the factors of 42, we listed the factors of 60, and then compared what we had. So the g.c.f. is 6. That's the largest number that divides into 42 and 60. All right, let's find all the common factors between 25 and 16. Let's do this the same way. List all the factors of 25. Now, 25 does not have a lot of factors. 1 in itself, and then 5 and 5. So that only has 3 factors. Even though you see 4 numbers listed there, there's 4 numbers here, there's really only 3 factors. Now let's do 16. 16 has 1 in itself, 2 and 8, and I think my PowerPoint's forgetting to put 4 and 4 in there. So all the common factors of 25 and 16, oh, there's my 4 and 4, is 1. The g.c.f. is 1. That doesn't seem very great, right? Greatest common factor, but that happens. Your g.c.f. sometimes be 1. Okay, one more example here, and this is an application problem. What we have is Mr. Elfman is splitting 6 girls and 3 boys into singing groups. He wants each group to have the same combination of girls and boys. What is the greatest number of groups he can create? Now with this, you might notice that the word greatest is in there. And greatest is usually a good indicator that you're going to be dealing with something like greatest common factor. If you see something where it says, the least number of people or least number of groups, that might have something to do with least common multiple, LCM, which we have not covered yet. We're going to be doing that next. I'm going to do this just like I would do any g.c.f. problem. I'm going to list the factors of 6, and I'm going to list the factors of 3. And then look at what they have in common. So 6 and 3 both have a 1 in common. That's a given. That's always going to be true no matter what kind of numbers you're dealing with. And they both have a 3 in common. I don't know why I didn't circle 3, but you can go ahead and circle it. But they both have 3 in common. There it is. It's just out of order, sorry. And that is the number of groups that Mr. Elfman can make. So every group is going to have 3 people. One boy, two girls. One boy, there's Jack, there's Fiona, and Carly. Okay, that's going to be a singing group. They're probably going to do a One Direction song with Fiona being in that group. And then there's Brandon and our friend Bailey, and that's some girl named Liv. All right, and they are going to be a singing group too. So we got our three groups right there. Okay, so we have Alan, we have Jenny, and we have Haley in that first group there. Okay, that does it for this lesson. Make sure you have taken good notes. Write down all the examples, and write down a small summary in your interactive notebooks when you're done. That does it. Have a great night. See you tomorrow, everybody.